you would. Recording is in progress. Brady has offered to start us off with an opening prayer. Then we've got a couple of announcements and we'll get things underway.
Our Father in heaven, we thank you that we can begin this seminar this morning, and we thank thee that thou hast provided us with moisture in the air. We thank thee, Father, that we can be in this institution and learn and have these experiences. We pray that we might have thy spirit here and that we might be engaged and learn a lot. We pray for the food that will bless and strengthen us. We say these things in the name of Jesus Christ. Amen.
Amen. Thank you. Okay, do we have an IPSO rep? Any announcements from the organization?
Okay, is a professional development workshop. Everyone needs to come.
Come to the professional development workshop on Friday, 10 o'clock in this room.
10 to 2, 10 to noon.
10 to noon in this room.
Yeah,
Hang out till 2 if you want, but professional development workshop is 10 to 12. Hope to see you there. Any other announcements from IPSO? Anything else we have there? Sign up for soup. Our department administrator, Jesse, has a request that we've got a couple of grad fairs, major fairs, and things like that coming up. Annie is going to send out to the student list a sign-up sheet. One of the best parts for people investigating our program is to have other students there, people who are currently in the program. So you can ask questions about what your experience is like, and it's just kind of fun, right? You get to be the expert, and you get to talk about how cool our program is. And so sign up. Annie will send that out. If you have a few minutes, you can look at the dates and times and everything like that. And we appreciate your help if you can sign up for a block of time there. Do we have any other announcements from anything? Make sure that we're doing make sure you're doing the other seminar assignments, teaching something you've learned, attending a defense, and so on and so on. Thank you for your participation in the quizzes. And I think we're probably ready to turn the time over to our speaker today, Rebecca Sansom. Oh, Brady, is there
a way that we can know when the defenses are happening beforehand?
Yeah, watch your emails. They're sent out a week, 10 days in advance, usually. Yeah, so they come from the department secretary to the student list.
Okay.
Rebecca is a faculty member in the Department of Chemistry and a great friend of our program. She's been associated with us in some fashion, I think, the whole time I've been here. She got her doctorate in our companion program, EIME, here in the college, and we're grateful for all of the influence she's had. She's currently working on a grant with Dr. Leary and some others that she'll be sharing some information about. We're grateful to have her. If you'll just join me in welcoming Rebecca and her colleagues to our seminar today.
Thank you very much. And I apologize for the mask today. I do have COVID, so I also have some face masks. If anyone wants a face mask, you're welcome to have one. I'll do my best to just project through it. But I'm really excited to be here today. Like Jason said, I did graduate from EIME in 2019. And then I thought, oh my gosh, 2020 is going to be the best year. I'm going to relax. And now we're in 2023 and what the heck, so anyway, I'm really excited to be here. I'm going to be talking about a project that we're doing that was funded by the National Science Foundation through the DRK-12 program. And Heather Leary, who you all know and love, is the co-PI on that. And there's several other people involved. So Tracy Polson is a graduate student right now in EIME. Some of you might know her. She's finishing most of her coursework. Max Longhurst is from Utah State. He's our collaborator there. And Austin Moore is a teacher who's doing the graduate program at Utah State. Josh Stowers is a faculty member here in the biology department. Michelle Hudson is our postdoc. She's in the back. Hi, Michelle. There she is. If you're wondering what a postdoc is, Michelle Hudson can help you with that. And we've got Clara Smith, who's a graduate student in the biological science education PhD program here at BYU. So also taking some of these courses over here in IP&T. And that's sort of our team for this project. We've been working on it for a few years. The original idea started in 2020. So I'll tell you a little bit more about sort of the evolution of this project and how it came to be. One thing that you should know is about three-dimensional science. So this might be a new term for those of you who aren't into science education, but it doesn't mean like three-dimensional in space. It means that science is taught using disciplinary core ideas, cross-cutting concepts, and science and engineering practices. So I'll tell you a little bit about what that means. This is sort of a new way of thinking about science education. In the past, science has been taught sort of as like a list of facts or things that you needed to memorize. And about 10 years ago, nationally, the next generation science standards came out. And those sort of reframed science and science education as being more sort of immersive for students and asking students, instead of just like memorizing a bunch of things, to actually do science using science and engineering practices like designing experiments and analyzing data. And to think about these sort of cross-cutting concepts would be something like matter and energy, or structure relates to function, big picture ideas. And getting students to kind of engage with these things so that when they're done, they can actually think like a scientist and they can act like a scientist, so they can do science. And this the next generation science standards have now been adopted by, I think we're up to like 44 or 45 states in some form. And in Utah, we have the SEED standards, which are our version of the next generation science standards, also three-dimensional, so purposefully sort of integrating these three different pieces. I know that's probably like new or different. So does anyone have any questions about like 3D science? It kind of makes sense? Okay, awesome. So you can imagine for teachers though, this is a pretty big change in what they're asked to do in classrooms. And so all of this was going on. The SEED standards were adopted officially in 2021. And we were thinking also about rural Utah. And the reason is, one of the reasons anyway, so I don't know whether you guys have seen a map like this before, but it sort of shows the density of the population in different parts of the state. And it turns out that every county in Utah, except for Salt Lake County, is classified as rural, even Utah County. Because there's a lot of places in Utah County that don't have any people there, right? So even though we have like sort of a city over here, there's a lot of places that are not populated. And so according to population density, every county is rural, but obviously these counties that are this very pale color, there's less than 50 people per square mile. That's like the most rural. And some of them are also considered frontier and remote, which means in addition to having a very low population density, they also are located very far away from any population density somewhere else. So for example, San Juan County is down here, and like to get to Provo, it's about a 4-hour drive. So they would be considered a frontier and remote area. So yes, on the Wasatch Front, so the populated areas right up at the top here, there was a lot of professional development going on. We have like Davis County, Alpine School District, Salt Lake, Jordan, Canyons. They're doing awesome things, having ongoing professional development, really working on these SEED standards and this new way of teaching science. And many of them had been working on it even for years, like before the standards were adopted, because the leaders in that district sort of knew what was going on, saw it coming down the road, and they had started working on that. And meanwhile, the teachers who were in rural schools generally just didn't have access to any kind of professional development at all. So many of the teachers that we had participating in our program actually didn't even know, when we asked them like, what's three-dimensional science? They didn't even know what the 3 dimensions were, right? So that's like the level that we're at. And then we want them to change the way that we're teaching science, right? So we were kind of aware of all of this, and we thought we would like to do something to help these teachers. And these red dots on the map, in case you're wondering, those are our 12 teachers who are participating in our first cohort. That's like their locations in the state. The rural parts of the state are served by these regional service centers as well. And so they're also our partners in doing this work. They help to provide PD for the people within their region. but usually the PD is like general kind of things like about reading or about technology and not really about science. Okay, so in order to get people to change what they're doing, we use this ecological model to think about it. We need to have positive attitudes and beliefs about the thing that we're asking them to do. They need to have skills and knowledge to be able to execute it. There's also expectations from colleagues, from supervisors, from parents, from students about what science is supposed to look like and what their classroom is supposed to be like. And then there's also issues like resources, time, money, policies, etc., that are influencing what people are doing. So we use this framework to sort of think about this problem. How do we get people to do this new kind of teaching? And so our goals are threefold. Our first goal is about the people themselves. Our goal is to build capacity among these rural teachers for 3D science teaching. And we also hope to strengthen their professional networks and their ability to have a critical friend who can help them think through something when they're trying to change their practice. Our second goal is principles, and that's related to technology-mediated lesson study, which I'll tell you about more in a minute, which is the strategy that we're using to do professional development with people that live so far away from each other. And we're trying to understand how that works and how other people could be able to use it as well. And then finally, we have products, which are the lessons that our teachers are producing through this process. So when we submitted our proposal to the National Science Foundation, these were kind of our three goals. And I think it's actually really unique and cool that we have this program that's called DRK-12, Discovery Research K-12. And unlike many grant programs, it has a dual focus. So they want you to have a substantive impact on practice, like helping teachers and making lesson plans and stuff like that, right? And they also want you to have a substantive impact on our knowledge about what works for professional development in this case, right? So research. And so it really has this dual focus. And that's been really exciting for me because I really like both of those worlds. The things that I'm interested in are usually at the intersection of research and practice. And so this is a program that allows us to really do both. So we know, forgive the picture, but the room probably looks familiar. This is our summer workshop that we did. And we know when we do professional development, like a summer workshop is awesome. But also, if we really want people to change what they're doing in their classrooms, then it needs to be ongoing. It needs to be collaborative. It needs to be embedded in their practice, right? And so for all of those things to be effective, we have a challenge for rural teachers, which is that they are so far away from other people that they often have zero opportunities to collaborate. So for example, I think we had 3 or 4 teachers in our initial cohort of 12 who were the only science teacher at their school. So they would teach 7 through 12 science. Every science that's taught, they teach it. They just teach a different class every period, and they teach all of them, right? And even for the people that had other teachers at the school, they might be the only one who's teaching biology. Like the other teacher teaches chemistry and physics. So like they can't really help if you have a question about biology. And so there's a lot of professional isolation. And in addition, because of their location, they're also often isolated from other opportunities for professional development, like through museums or universities or other things that might be located in urban centers. So we decided to draw from a professional learning strategy that's called lesson study and modify it. So in lesson study, you would have a group of teachers, so like 4 teachers. They would get together, co-design a lesson, targeting a specific goal that they share for their students. One of them would teach the lesson, and the other 3 would be present in the room, sort of sitting in the back, observing, looking for the ways that students are responding to the lesson. Are the elements of the lesson resulting in the student learning that we hope to see? And then they get together afterwards, and they talk about the lesson, what worked, what didn't work. They make revisions to the lesson, And then another teacher will repeat the process. So they'll go through this iteratively several times. And you can see from that description, this includes being collaborative, being ongoing, being practice-based, all of those things that we want to see in really high quality professional learning. Of course, you can also see some challenges for rural teachers. The first one being there aren't 4 teachers in their school who could help with this process, right? And so we decided to make something called technology-mediated lesson study. We still bring the teachers together at the beginning to design the lesson together in person. But then they go to their schools and they use a swivel camera. This is like not the updated version. We have a cool picture that has a swivel camera in it. Do you guys know what a swivel is? Yeah, it's like a little robot and it'll just like follow the teacher around basically. It stays in one place, but it just kind of swivels, right, to follow the teacher. And it also has some audio markers. So you can put them to listen to a student group, a particular student group if you want to listen in on those. So the teacher teaches the lesson, they record it with the swivel, and then the other teachers use the swivel platform to look at the recording of the lesson and listen to what the students are talking about. And they can asynchronously go in and leave comments that they're like time-stamped comments on the lesson. And then they can get together synchronously on Zoom and they can talk about all of the stuff that they saw in the lesson, revise the lesson, and again, repeat the process where one of those teachers will then go on to teach the lesson next. So for our professional learning, we started with a summer workshop. It was 5 days in person. We were learning about 3D science and the teams co-designed the first lesson. Then they have a TMLS cycle where they do all 4 of those iterations. And then we would meet together for a weekend workshop. So 4 times throughout the year, we repeated this cycle of doing the TMLS and getting together for the weekend workshop to make the next lesson. At the last weekend workshop that we did, they actually helped to plan the summer workshop for the next year. So I know that was like a lot. So any questions about what we did there? Is that like clear? Yeah.
Do they then just come away with 4 lessons?
Yes.
After that? Okay.
Yeah, so each team will have created 4 lessons. Yeah.
Principles that they use in their other lessons.
Yes, exactly. Yeah, that's a great point. And one of the things that we're really interested in is whether this professional learning is then resulting in them taking different approaches to their other lessons, right? Not the ones that they designed here, but like, is there some sort of diffusion, right, of those ideas? Because obviously, like, there's more than 4 lessons in a year. So we hope that that's true. So for the research that's sort of like overlaid on the top of this, we're using design-based implementation research. And this is in collaboration with the regional service centers and the secondary science teachers. And essentially, it means that we're looking at what works in the classroom in implementation and adjusting our research as needed along the way when we find out what's working and what's not working. We're using convergent mixed methods research. So our quantitative work is the social network analysis. I'm going to talk mostly about that today. And that means that Michelle, maybe, or Clara another time, or Heather could come talk about the case study that we're doing for the qualitative piece. For our participants, we did a pilot year. And in the pilot year, we had 4 teachers who participated who were, we called them science teacher leaders, and they were sort of in training. So they did kind of, they participated as teachers, you know, in a sort of first draft of our workshop. They did a kind of first draft of this technology mediated lesson study so we could see how it worked and like what, you know, problems we ran into along the way. And then they became the science teacher leaders for the second cohort. So 3 of them continued and we had 9 new participants, so 12 total. They were divided into 3 teams of 4 people each. And then this year, we've got 6 STLs and 18 participants. And again, about 6 teams of 4 people. So I'm going to be reporting on results mostly related to this first cohort of 12. So There's a bunch of ways that we're collecting data. I'm going to talk mostly about this social network analysis survey, but we also do interviews. We have the recordings of their classes. We have the comments that teachers leave on those recordings. We have focus groups that we've done during the weekend workshops. A lot of really rich observation data and lesson artifacts. So a lot of that qualitative stuff can be really descriptive and rich. Yeah, I'm not going to talk about it. So why? Because I can choose. And my dissertation was qualitative, and then I was like, I don't want to do that again. Okay. So we've got 3 big questions here. Sorry, Dr. Yanchar. Okay. Bye. Please do not be offended. The big question that I want to talk about is, does technology-mediated lesson study help teachers build social networks and communities of practice that support the enactment of 3D science teaching? How and why? And I'm going to really talk about this, the change in that social network that we're observing. So what we did for the social network survey is that we sent a survey out to all rural chemistry and biology teachers in publicly funded Utah schools. So in those 4 regions of the state that we talked about. And we invited them to complete the survey. It asked questions about demographics and teaching experience, and also their professional networks. And then they were given a list of all of the other teachers that were in the population. There was about 100, a little bit more than 100 teachers. So they were broken up into chunks, but they had a list of everyone. And they were asked who they seek advice from, who they collaborate with, and who they consider a close friend. And these 3 questions are important because they're giving us sort of a different information about the ways that people are interacting with each other. So an advice network tends to be informal, just like people you ask for advice. So it has an element of identifying expertise in others. It has an element of trust or vulnerability on the part of someone asking for advice to say, like, I need help with something. So it kind of has both of those pieces. Collaborate tends to be more related to the structures that exist within districts. Like if your district has a PLC, then you would collaborate with those people. So it tends to represent something more formal, and they're not necessarily people that you like or trust. They're just people you have to collaborate with, right? And then we have a close friend, and this was defined as somebody who you shared details about your personal life, or you might, attend family events together or other things like that. So that's sort of a high bar for teachers to know each other and consider each other friends. So we collected data prior to the summer workshop and then again near the end of the year-long program. And we used a program that's called UCINet, which does social network analysis. So social network data presents a problem for statistics because it violates the assumption of independence. I don't know, has anyone taken statistics yet? Yes? Like independence is the first assumption. Some people are like, no, I will never take it. Is that true? You never take statistics?
Take it.
You will take it. You did take it.
Yeah, I took it in my MPA.
Okay,
So I
cool.
did a different program, but yeah.
Okay, awesome, good. So like independence is the first assumption that you've got to make with all of the statistical tests. So UCINet uses a different method, which is called permutations, to identify whether the changes that we're seeing are significant or not. If you want to know more about that, I'm happy to talk about it later. So this is what's called a sociogram. And in the sociogram, this was the advice network from 2022. Each of the dots or squares represents a teacher within the sample or the population. And the lines between them represent ties or connections. And they're directional. So for example, this person says, I asked this other person for advice. And this person here says, did not say that they asked that person for advice. So this was like a one directional tie, but you can also have a reciprocal tie, like this tie is reciprocal. Okay. If you see dots that are by themselves, that means that that teacher identified 0 others within the population that they ask for advice about their science teaching. And 0 other people identified that person as someone that they ask for advice. So we call those isolates. Some of them were actually isolates in all 3 networks, so they're kind of off to the side here. And others of them are kind of mixed in because they had connections in some of the networks, but not others. And I put a little circle around each of the participants that we have data for. We have data for 10 of our participants for both time points. What are some things that you notice about this sociogram? Yeah.
There's a lot of individual teachers that don't ask anyone for help.
There's a lot of people who don't have anyone to ask for advice. And in fact, 0 and 1 were the most common responses for people. Who do you have to ask for advice? Nobody, or 1 person, right? Were the most common responses. Yeah.
Of the ones that do ask for advice, they tend to stay more in their little sphere versus like, do you have a few lines coming out, but isn't a ton of cross community.
Yeah. Thank you. And thank you for pointing out. So like, this is an example of a district that has PLCs. Right? And these are actually organized by the 4 regions of the state. So they do represent some kind of locality, right? People who are located close together. And in fact, that was also something that we found. There was very few connections that crossed district or region boundaries. Yeah. What else?
Looks like some regions are doing better than others.
Yeah, some regions are doing better than others. Like this one seems to have a little bit more connection going on, maybe. This one's not doing so great. A lot of isolates over there. And sometimes that's because of the nature, like some of these are very rural, and these teachers represent a person that is like, 50 or 100 miles from the nearest teacher in their own district. And sometimes they're in a big district with other teachers at the same school, and they could be collaborating and they just don't. So both of those things can happen. Great. So this is what we saw in 2022. And then when we did it again in 2023, this is what we saw. And we thought, oh gosh, we did a good job. So really exciting to see just like an actual visual impact. Yes, there is more advice seeking happening here. And we wanted to also sort of quantify this as well. So I'll share with you some of the ways that we quantify it. But you can see like this person, for example, now has several advice connections, and actually several people are asking that person for advice, which is interesting because when the teachers are not connected, they're not able to recognize expertise in others, right? And you may have a teacher that's out by themselves, like doing great things. And as soon as other people know about them, they're excited to ask them for advice, right? So that was awesome. We saw similar things with the collaboration network. This was our 2022 and our 2023 collaboration networks. It's important to note here that like our professional development was a kind of collaboration. So like people who participated should have said, yes, I now collaborate with these people in my group, which is the 3 other people in their group of 4, right? But they wouldn't necessarily ask that person for advice, and they wouldn't necessarily be that person's friend, but they should have collaborated with them. And one of the exciting findings that we have is that for our teachers who participated, the number of people that they say that they collaborate with is the number of new people is actually greater than 3. So it means that they're collaborating with additional people, both within the program and without the program. We have a similar thing with the Friends Network, not as dramatic, but more friendship connections. This is the one that I think makes me like the happiest of all, because I think it's such a high bar, right? But we have teachers who now are making these really rich types of connections, right? Somebody that they ask for advice and collaborate with and consider a friend and maybe talk about their families and stuff like that, right? So that's all really exciting. So the way that we analyze this in social network analysis is that we do something called a churn analysis. And what it's going to do is it's going to allow us to see both what changed from year 1 to year 2 and also like how that change happened. So for example, if we look at this person in the center, in year 1, they have 5 ties to these 5 people. In year 2, they also have 5 ties. But 4 of them are kept ties or maintained ties. They lost this tie and then they have 1 new tie. And so this churn analysis allows us to see sort of how those changes are happening within the network. And in order to make sure that we can compare the participants and the non-participants, we looked at the baseline for their original networks. And for advice and friendship, the network sizes were not significantly different from non-participants at the beginning, although people who participated in our project did on average have 1 or 2 more collaboration ties. So sometimes that just tells you like about the nature of the district that they come from, that they're more likely to have sort of structured collaboration. Additionally, participant teachers lost and kept advice and friendship ties at the same rate as non-participant teachers, but they kept collaboration ties at a slightly higher rate. So they started off with a few more collaboration ties and they tended to maintain them, again, probably due to the nature of their district. But we took this as like pretty close to comparing the same thing at the beginning. And the one that we really should pay attention to is the number of new ties. So we looked at new advice ties, collaboration ties, and friendship ties. And for participants, the number of new advice ties was about 7, whereas for non-participants, it was 1.5. For collaboration, the number of new ties was about 6 versus 1 for non-participants, and new friendships 3 versus 1 for non-participants. And this is where I think it's really exciting to see impact beyond what's sort of dictated by the professional learning that we designed. So teacher have 6 new collaboration ties. For some teachers, that was because a teacher in the group over here was like, oh, I want to hear about what you're doing over there. Tell me about that lesson. Let's do that together. I'm going to try it in my classroom, you know, and they would start collaborating across groups. And for some teachers, it's because they actually started collaborating with teachers in their same school or district that they hadn't been collaborating with previously. Both of those are exciting, I think. So all of these were significantly different. Now, let's say this is your statistics test for the day. If you had a group of participants and non-participants, you wanted to compare them, and then you wanted to look at like time 1 and time 2 and how they were changing, what kind of statistical test would you do? Paired samples, but I have 2 groups that I want to compare. A split plot ANOVA. Split plot ANOVA is what I would do. Now I'm gonna, thank you, well done. He gets a gold star. So you do a split plot ANOVA. Now I already told you, you're not supposed to use regular statistics for social network data. And that is still true. So I'm gonna show you some split plot ANOVAs with an asterisk next to them. They're just here for visualization purposes, not because it's a valid way to analyze the data, but because it helps to just see what the difference is between participants and non-participants in the size of their networks. Again, these were like all statistically significant, but it's not a valid way to analyze the data. So just for your edification. Okay. So what are the things that we can conclude here? We found that participant teachers had significantly more new ties versus non-participants in all 3 networks: advice, collaboration, and friendship. And that the number of new ties exceeded the number predicted by the structure of the professional learning experience. which means that people are starting to collaborate even beyond what we intended. Additionally, the ties that are formed are strong multiplex ties. It's called multiplex in social network when the tie is in response to multiple different prompts. They're a friend, I collaborate with them, I seek advice from them. So we believe that TMLS is an effective strategy for building professional networks of rural science teachers. And because of the multiplexity of these relationships, we believe that they will endure beyond the length of the program. That's been shown by prior work. And one of the things that we're really interested in is the nature of these kept, lost, and new ties. So for example, one thing that we're hoping to do soon is look at whether the new ties for non-participants were actually the result of them interacting with participants. And other things like that. We're also really interested in how, what the interaction is between district structured, interactions, I guess, like PLCs, and these informal networks where people actually go to get advice or to collaborate. So thank you to these wonderful people. Thank you to the National Science Foundation for giving us funding. We have a website if you're interested, and we have some references for you. And thank you for your time and attention. So I'll gladly take any questions that you have. Yes.
In the beginning, you talked about the network. Are you assuming that the community network is important or necessary? I mean, some of these people are frontier rural, maybe they don't need to interact or care.
Yeah, great question. So for the purposes of this study, we have this kind of bounded population, which is these like rural secondary science teachers, right? And when a teacher finds themselves in a situation that there are no other teachers around, you're absolutely right that it's not likely that they're going to go find a science teacher like somewhere 100 miles away and be like, hey, can we collaborate on something? And instead, what we've also found, and this is another area that we're continuing to investigate right now, Tracy's working on it, is that those teachers actually leverage really interesting and unique resources in their community. So for example, there might be like the guy that gives out the deer tax in their county. And like everybody knows that guy. And like that guy actually knows a lot of stuff about population ecology. And maybe we can leverage that resource as a connection to talk about something when we have a question about that. Or, maybe there's like in Carbon County, there's mining nearby. And maybe there's some people in the community that work in the mine that might be able to help us when we get to the chemistry lesson about mineral resource management, right? And so you're absolutely right that these teachers, like on the one hand, we painted a sort of a bleak picture of teachers who are really isolated and who don't have anyone to ask for help, right? But on the other hand, what we've found as we've talked to those teachers is that they're very resourceful and creative in finding ways to get help that they need within their communities. Yeah. So we're investigating that, and it's a great question. Yeah. Was there another one here? Yeah.
Of the 12 people in the first cohort, did you like have a hard, were they they just volunteered? Were they really excited and you had to like, not now, but maybe next cohort, or was it like?
Great question. So like, yeah, everyone who did participate did volunteer. But we took everyone. So like, there was no one extra that volunteered. We were like, not this year. So we were actually hoping to have more in the first cohort. And, but it's a hard time to recruit teachers to do a kind of intensive year-long PD program coming out of COVID. When a lot of teachers are like really burned out and didn't want to do it. So the recruitment has been a little tough. It has been great though. Like of our 12 teachers, we had 10 basically who came back for the next year. 9, I guess, because one of them became a graduate student, so he's not participating anymore. But anyway, so there is like a lot of the people who are participating in it are finding a lot of value in it. And then they're also like bringing friends and colleagues for the next year. Like 40% of our new participants came from a connection with an old participant. Yeah.
So at the beginning, you implement the 3D science, and then I like you're trying to use to explore the interactions between teachers, and then have you got a chance to like evaluate how the teachers really implement those?
Yes, yeah, great question. And the answer is yes. That's what we're working on with our case study, is actually to look at the changes in the ways that they're implementing 3D science instruction in their classroom. And what I can say right now, we haven't analyzed all of the data. What I can say right now is that teachers recognize in themselves a shift in the way that they're thinking about it. And they recognize the knowledge that they've gained over the course of the year. They're able to speak about those 3 dimensions correctly and intelligently and deeply at the end of the year. Whereas at the beginning of the year, one of them, when we asked him about 3D science, said, can you tell me what it is? I don't know. And so we are seeing definitely a shift in their understanding. And anecdotally, we're seeing a shift in their implementation in their classroom beyond even the lessons that they designed together. Those lessons are absolutely 3-dimensional. But beyond that, they report that they're starting to think about the questions that they're asking in their other classes or in their other lessons. They're starting to think about, oh, how do I make this? How do I add in some more science and engineering practices in this lesson? And so we do see that anecdotally. We're working on developing an instrument that we can use as an observation instrument that would allow us to evaluate the 3-dimensionality of their teaching when we observe a lesson. So we can have something sort of more quantitative, I guess, for that. Yeah. Great questions. Yeah.
Since this is a national standard, is this being published like as here's an idea to use like nationally? Have you seen it picked up anywhere, or has it
we're
helped that way?
So we're working on, in terms of the lesson plans that they've created, we're working on getting them onto the website of the National Science Teaching Association. So they have a review process that we've started with the lessons from last year. And we're just, we should be getting feedback in the next week or 2 from them about how those lessons passed their review and, whether they can be posted on their website. So that's yes for that. And then also, like, obviously our research, we're working on sharing that. So we have a paper out right now. We're revising, we've got it back. And we're revising and resubmitting about the process of technology mediated lesson study. And we have another paper out that was about like our baseline social network analysis that we did at the beginning. So just sort of characterizing rural science teachers before we did anything. Yeah. Yeah.
I'm just curious to hear about what personal lessons you learned conducting this type of research study and then just working on a team that had several people, like how
Yeah.
did the dynamics work?
What a great question. I think one of the things that has been like really wonderful and rewarding for me has been working with a team of really diverse people in the sense that they come with very different expertise. So like Heather, for example, is our design-based implementation researcher and our like expert on research practice partnerships. So working with having researchers working with teachers in a way that is like more equal, as opposed to like, the university coming in and saying, this is what we're going to do to you, and that has been really instructive for me. I think personally, I don't know that that's necessarily like a thing that I learned. Like I gathered these people together when I wanted to start working on this project. So like, I think it's a thing that I appreciate, that like people have different expertise and they bring that to the table and we can all contribute in a way that makes everybody better. And this is a huge project and we just literally wouldn't be able to accomplish it without everyone's best efforts. I think some of the things that I learned, I think that I actually live up in Heber, which is one of the rural areas of the state. I live, like my neighbors have horses and hay fields, and I just have like nothing. There's nothing around me. And I love it. It's beautiful. But I think that I had sort of an idea about what rural teachers experienced, and like had more of a sense of the isolation and lack of opportunity than a sense of the creativity and resourcefulness of teachers who find a way and make a way and come up with amazing ideas and lessons. And so I think the thing that I appreciate more now than I did at the beginning is the ways that these teachers are just like outstanding individuals who are bringing their best to the classroom every day and being creative. And sometimes we have a view of rural areas as sort of like lacking resources and lacking opportunities. And I would say like we've learned the opposite. There's a lot of resources and a lot of creativity and a lot of opportunities for teachers. So yeah. All great questions. Do we have any? Is there any questions from online?
Not that I've seen.
Okay, awesome. So thank you. Hopefully this is a helpful, good discussion, and enjoy your soup.
All right, let's thank Rebecca one more time. Thank you.
I did not bring soup. I was in here.
And I got
Having some tomato soup out of the cupboard and heating it up. I did. I hope I didn't ruin it. It's like started up like boy thing. Too hard. I was gonna check on it.